friends, today we will learn how to convert a epsilon-free NFA into an equivalent DFA. Here I am taking an example. In this example, this is the given NFA, that what we need to convert it into an equivalent DFA. That you can look at here on Q0, on input A, we can either reach to Q1 state and on Q0 state. It represents that this is a NFA. We have two final state in this NFA, one is Q2, one is Q3, and the initial state is Q0. So there are certain steps that we need to follow to convert it into a DFA. So this is the first step. What we need to do, we need to find the transition on each state on every input symbol. So we have two input symbol A and B. So what we need to do, we need to find the transition of A and B on this Q0 state. So let's suppose this Q0 state we are writing here, and this delta symbol is showing the transition, and on input A, if we applying it onto the Q0, so where we can reach? We can reach the state Q0 and we can reach the state Q1. So we are uniting these two states in a new set. And if we put the transition B on Q0, so we are reaching again to the Q0. This Q0, we are naming it A, and this set which is having two states, we are naming it B. Now what we need to do, we need to apply the similar algorithm on these two sets. But always remember, if on any of the set you have already done it previously, then there is no need to do it again. Like in this example, if we will apply the transition of A and B on this set A, so what we will get? In the set A, there is only one state, it is Q0, and on Q0 we have already identified the transition of A and B. So it means we will not use this set again to find the transition. But on B, there is no transition we have already applied, so we will apply the transition of A and B on this B. So in the step 2 we are doing that. On the set B we are applying the transition A, on the set B we are applying the transition B. When we apply the transition A on this set, we can reach to this set of states. Just look at it here, how this we are getting. In this B, it is a group of two states, Q0 and Q1. So what we will do, we will apply the transition A on the state Q0 and on the state Q1 independently. Then we will make the union. And finally, we will get the resultant set. So just look at here, A. If we will find the transition of A on Q0, we can reach to Q1 and Q0. This is what we are writing here. But when we apply the transition of A on this Q1, we are reaching to Q2. This is what we are writing. And here we have got a new set. Because it is a new set, so we are giving it a new name, that is C. Now on this B, we are finding the transition on the B input symbol. If you apply the B input symbol on the B, so on it is the B state, B set is the Q0 and Q1. On Q0, if we apply B, we are again reaching to the Q0, and on B set, if we apply the B transition on Q1, so it will remain on the Q1. So this set is having only two states, that is Q0 and Q1. If you look at here, so this set is already a identified set. This set we have already identified in step 1. So we will name it same as we have already identified. So what we can write, this is the old set. Now on this C set, we will repeat the process. So on C set, we are finding the transition of A and B and trying to find the new set of states. So when we apply the A transition on this C set, so there are three symbols Q0, Q1 and Q2. So first we will apply the transition of A on Q0, then on Q1 and later on Q2. And finally we will get the union of all those transition and get the new set. So we apply the transition of A on Q0, we will get the Q0 and Q1. If we will apply the transition of A on Q1, we will get the Q2. If we will apply the transition of A on Q2, we will get Q3. And this set has not been identified yet, so it is a new set, so we are naming it D. And in this step 3, we are transiting B on the set C. When we apply the B transition on the set C, when B will transit on Q0, it will give Q0. When B will transit on Q1, it will give Q1. When B will transit on Q2, it will give us Q3. Again, this set has not been identified yet because it is having Q0, Q1 and Q3. We have not identified yet. So this is a new set and we are naming it E. We will repeat this process until unless we are finding the new sets. When the new sets are not able to find, we are not able to find the new sets of states, then we will stop this process. So in the step 4, we will transit A and B on the set D. So we will apply the A transition on the set D, we will get this set of states Q0, Q1, Q2, Q3. Just look at how. On Q0, A transition will give us Q1 and Q0 and Q1. On Q1, A transition will give us Q2. On Q2, A transition will give us Q3. And on Q3, there is no A transition is available. So it means this is already a old state which is identified earlier. Now we are having B transition on the set D. If we will do that, we are finding this set of states Q0, Q1, Q2, Q3, and this is already identified. So again it is the old set. Now which set still is remaining on which we have not identified the transition of A and B? This is the set E. In the step 5, we will apply the process. If we will apply the process of transiting A and B on set E, we will get these sets of states. And these sets of states are already identified because on A transition we will get Q0, Q1, Q2, Q3. This is the set D. Or on B transition we will also get the same set of state. This is the set D. It means now no set is remaining on we have not applied the transition A and B. So now here we are making the transition table of equivalent DFA. Because in this A set there is only one state, that is our initial state in given NFA. So we will consider this A state as an initial state. On A move, this initial state is giving us B state and A state on B move. This is what we are writing. On B set, on B set, on A move we are getting C set, and on B move it is giving us the B set. So this is what we are writing. In the same way we have completed our table. Now the important question is that how we need to identify the final states in this transition. So final state will be all those sets in which this Q2 and Q3 are coming. So in which sets the Q2, Q3 are coming. So just look at here, Q2 and Q3 are coming in the set D. So we will consider this D as a final state. If it is coming in any other set also, then we will consider that set also a final state. So in E we are getting the Q3. It is not compulsory that both of the states should become. If any of the state is coming in the set, we will consider the entire set as a final state. Because Q3 is coming into the set E, so we will also consider E as a final state. So this is the transition table of equivalent DFA. if we make the DFA with the help of this transition table, so how we will do that? First we are making the initial state A, then on A move it is taking us to the state B, and on B move it will remain here only. On A move it is taking us to state C, and on B move it will remain same at B state, and on A move it is taking us to set D, and on B move it is taking us to set E. Set E, and these two from state E we will reach to the state D, and on B move again we are reaching to the state D. So this is the equivalent DFA of given NFA. Hope the concept is very much clear to you. If you people have any doubts, you can ask any query into the comment section. Thank you very much.